Hello, we will get to know how to do math of future value of ordinary annuity and annuity due and present value of ordinary annuity and annuity due. Let's move forward. Now, you are surprised, right? That why I'm showing you Indian squad, because there's a reason, because we often don't remember which one is annuity due and which one is ordinary annuity. So this is just an interesting example. If you can remember it, now you'll never forget about this distinguishing for ordinary annuity and annuity due. Now Rohit Sharma, you see the first batsman is Rohit Sharma and the last batsman is Jasprit Bumrah, right? Now, what do you think? Jasprit Bumrah is as good as Rohit Sharma? No, because he is an ordinary batsman. That's why he comes to bat at 11. Now, Rohit Sharma is a very good batsman. He's a legend. He's a fine batsman. That's why he comes to bat at first. So batsmen who bat at the beginning, because they are very good batsmen, and people, the players who come at the bottom, because they are ordinary batsmen, right? So the batsman Jasprit Bumrah, we can say that Jasprit Bumrah is ordinary annuity because he comes to bat at the last, and the batsman who comes to bat in the first is annuity due. So we'll get it clarified once we do the math. So this is just an example, so to remember that if the in the math, if it is mentioned that the payment is made at the beginning, that means it's annuity due, and if the payment is made at the end, is that means that is ordinary annuity. Okay, this is how you can remember. Now, suppose you deposit $1,250 at the end of each quarter in an account that will earn interest at an annual rate of 10% compounded quarterly. How much will have at the end of 4 years? Now, at first we have to identify that this math is for annuity or just simple future value and present value math. So to know this, if you see that there is a series of payment like 1250 at the end of each quarter, and the payment will be made for 4 years, so this is a series of payment. Okay, so from that we get that is a math for annuity. Now we need to know that whether they're requiring to know about the future value or the present value. To know that, let's read out the last question: how much you will have at the end of 4 years. That means you have to identify the future value. Okay, now this is a future value of annuity. Now which annuity? Annuity due or ordinary annuity? To know that, just read out the first sentence. Suppose you deposit $1,250 at the end of each quarter. See, at the end. So who best at the end? Ordinary people, that means ordinary annuity. This is a future value of ordinary annuity math. Okay, and so the formula is future value of ordinary annuity is equal to payment into 1 plus r to the power n minus 1 divided by r. Now there is a problem here. It says 10%. R means you can denote it by I also, but I feel it comfortable to use R to denote interest rate. Okay, so here R is 10%, but it's compounded quarterly. Quarterly means 4. Okay, so we have to divide it, this R, by 4. Okay, and multiply this n by 4. N means year. How many years? 4 years. You see here, 4 years. So this n will be multiplied by 4 because it's compounded quarterly, and this r again will be divided by 4. So according to the formula, see, the payment is 1250 and 1 plus r is 10%. Here interest rate is 10%. 10% divided by 4 because it's compounded quarterly. If it would say compounded semi-annually, then semi-annually means 2, so r would be divided by 2 and annual would be multiplied by 2. This r would be divided by 2. Okay, if you would say that it's not semi-annually or quarterly, is monthly, so that means 12 months in a year. So this r would be divided by 12, n would be multiplied by 12, and all are like in the formula everywhere you see the r, that would be divided by 12, and the n would be multiplied by 12. Okay, so it says that compounded quarterly, so that's why at 10% divided by 4 to the power year 4 multiplied by 4 minus 1 divided by here r 10% divided by 4. Okay, so the result is $24,225.528. This is our first math. Let's do the second one. Assume deposit of BTT 1000 are made, BTT is Bangladesh Taka, 1000 are made at the beginning of each year for a period of 5 years. Okay, and interest is compounded at an annual rate of 5%. What is the future value at the end of period for a series of deposit plus all compounded interest? Okay, so we get it that from series of interest is mentioned here, so we get it is an annuity math. Now, which annuity, future or present? So what is the future is directly mentioned here, so you have to identify the future value of annuity. Now, which annuity, like annuity due or ordinary annuity? So you see here BT 1000 are made at the beginning. So beginning, who comes to bat at the beginning? Annuity due, not ordinary annuity. Okay, so this is an ordinary annuity due math, because the payment is made at the beginning. At the beginning means annuity due. So annuity due formula is very similar. So you see, there is no difference between the previous formula. Like ordinary annuity and annuity due formula is similar, P into 1 plus r to the power n minus 1 divided by r, but the only addition is multiplied by 1 plus r because it's annuity due. Otherwise the formula are very similar, right? The first portion is very similar for ordinary annuity and annuity due. The only addition is 1 multiplied by 1 plus r. Okay, so according to the math, so you see payment is 1000 here, 1000 multiplied by 1 plus r is 5%. Now you see there's annual rate of 5%. It's not said that compounded monthly or quarterly or semi-annually, that means yearly payment, so you don't have to divide anything. Okay, so the interest rate will be very simple, like 5%, no division, to the power r is to the power n is 5%, 5 years. Here is 5 years. For 5 years is the investment is made, right? So to the power 5 minus 1 divided by 0.05, which is r, right, multiplied by 1 plus r. 1 plus r means interest rate is 5%, 1 plus r, that's it. So the result is $5,801.91. Now let's move forward. Assume an individual is considering an investment that will provide a series of annual cash receipt of 500 for a period of 6 years, and the investor desires a 6% return. How much should the investor pay for the investment today? Okay, now from the last question we can identify that it's a present value math, right? Because they want to know that how much should you invest today, so the present value, okay, of the future cash flow. So we get it. Now we have to identify that whether it's an annuity due math or ordinary annuity math. Okay, so from the beginning, let's read it out again. Assume an individual is considering an investment that will provide a series of annual cash receipt of 500 for a period of 6 years, and the investor desires a 6% return. How much should the investor pay for the investment today? Now, have we found out anything mentioned about the beginning payment or ending payment? It is not mentioned here that this 500 is paid in the beginning or end. When it will not be mentioned in a math, we have to assume that is an ordinary formula, so we have to do according to the ordinary formula. Okay, if it's not mentioned. If it's mentioned, then we have to do the math according to the formula. But if it's not mentioned, it's simple and ordinary math formula. Okay, so the present value of ordinary annuity is equal to payment into 1 minus 1 divided by 1 plus r to the power n divided by r. Okay, this is the formula. Here payment is 500, right? If payment is 500, 1 minus 1 divided by 1 plus r. Here r is 6%. You see, 6%. And you have to be very clear like you have to be very careful while doing this, putting this R, because you have to see that whether it's compounded monthly or yearly, okay, or semi-annually. So it says that it doesn't mention anything like that, okay. And you see the annual cash receipts is 500, so there's no compounded monthly or annually, so this is yearly payment. So 1 plus R means 1 plus 0.06% to the power for how many years? 6 years is given here. 6 years to the power n is 6 years divided by R 0.06. Okay, so the result is 2458.66 dollars. Now this math, have a look at this math and let's read it out. Suppose you have the opportunity to make an investment in a real estate venture that expects to pay investors BDT 750 at the beginning of each month for the next 6 years. You believe that a reasonable return on your investment should be an annual rate of 15% compounded monthly. How much should you pay for the investment? So how much should you pay for the investment? That means again it's a present value formula, okay. Present value of ordinary or annuity due, because the payment is made at the beginning. It is clearly mentioned here, beginning means annuity due, right? So the formula is similar to before. The formula of present value of ordinary annuity and present value of annuity due is very similar, very same. Payment into 1 minus 1 divided by 1 plus R to the power n divided by R. So this addition, like similar to future value of annuity due, you have to add this 1 plus R. So that's the formula of PVAD for you. Here payment is $750, okay. 1 minus 1 divided by 1 plus R. R is 15% and it's compounded monthly. So you have to divide it by 12. So I think that I have made a mistake here. Let's clear it out. Like 15 divided by 12. See, I made a mistake here. Again 15 divided by 12. 1 plus 15 are divided by 12. Okay. So the result would be 42,316.17. I'm sure that the result is not wrong. I will recalculate it and you'll get the answer in the description box, and also in the comment section you can check it out if because I don't know how I made this mistake, but it said that compounded monthly, 15% compounded monthly, that means 12 months in a year. So 15% would be divided by 12. Then this, okay, again another correction, this 8 would be multiplied by 12 as is for 15 is compounded monthly. So this n would be year would be multiplied by 12. Okay, I think there's nothing else to make the correction. That's it. Thank you very much for watching.